Take a look at another advanced module here. Under walls, we've got wood shear wall. We're going to call this BWL3. And while this will do wood shear wall analysis, what it's actually going to do for us here is braced wall line analysis. And we start with this 8-foot length. I want this to be 13.5 feet. And then I want more on this wall line. I go over here to the left under this button under walls, stud wall plus continuous footing. You can see in the icon we've got a stick-built stud wall on top of a strip footing. And that's what this gray outline here means. We've got a footing underneath this wall. So as we draw additional segments of this wall, we're going to make a braced wall line assembly and not just individual shear walls. So I'm going to draw off the end here, go down 3 foot. And let's see, let's go to a 3D view. So right now we're single-sided. So if I look at the other side, I can see the studs. Which means, I believe I'm going to have to draw the next segment off the bottom. Oh, click to do more wall. This one's going to be 8'6". Come back up 1'10", and yeah, that's not going to work. And we've got a 7-foot wall. Aha, I've got to come off this side. There we go. Great. Go back to 3-dimensional view, and there we go. We've got 3 wall segments connected by 2 jogs. Go back to plan view. You'll notice this dashed line, and this is actually the center of resistance or stiffness for this wall line. Amazing. All right, well, if we go over here to the left, let's grab a door, and we've put that into the middle of our 13'6" wall. Grab a window, drag and drop it over in the middle here. Finally, we'll leave the 7-foot wall alone. So there we go. We've got a door and a window. We'll leave those to the default size. Obviously, you can go in and manipulate those and change the size and the layout, the position. All right. So we've got currently Alaskan cedar. Let's go back to some SPF. Number 2, 2x6s. Let's try 16 on center, 'cause this is a tall wall. And we've got 7,800, not 78,000. Wind, 4,600 of seismic. Structural 1. Probably going to need it. Okay. Well, let's take a look at our wall line. Calculate, and it's going to evaluate all the segments of wall we have here. So we've got 2 perforated wall segments and then a solid wall segment, and it's going to divvy up our lateral forces by relative stiffness. Whew, there we go. Looking at segment 1 here, we're at 99.5%. And it is controlling and that makes sense. It's going to soak up most of the load with that big unbroken length. We've even got a door in our door opening now. And here we go, a nice compact report, 2 pages, gives us the deflections of our wall segment. And here is a free body diagram for our wall segment. So this is for the far right wall, the 7-foot wall. We have no openings in it. And what it looks like is happening is it's taking all the lateral load because we put in openings that subdivided our other walls into too small of panels. Not surprising at 12 foot tall. So we can see we've got hold down forces. We've got our continuous shear along the bottom, and even shows the mass of the wall. And I love the red flags to tell us that yes, we do have net uplift. We are going to need hold downs. Fantastic.